Hello, my name is Nathan Starkel.
And I'm Ryley Rodriguez.
And I'm Connor Grace.
And this is our implementation video for our term project. Now, as you can see, we have our C file open, and our part 3 is actually split into two portions in that we have the insertion sort as well as a linear search implementation. Now, I'm going to briefly go over the insertion sort's printing algorithm in that we use a pointer in our C file to point to the memory location of our final array after it has been sorted, and then we use this for loop here to print out the content to our end user. So now I'm going to briefly go into the insertion sort code, and as you can see, we have a C implementation of our insertion sort up on the left here, and we use this very closely to make our assembly source file, and that it really did help in the construction of it. So as you can see, we have the initialization of I to 1. The construction of it is very similar in that we also have a loop 1 tag, which represents the for loop, the loop 2 tag, which represents the while loop, the increment I tag, which represents the incrementation of the outer for loop, and the exit tag, which returns our final array. So as you can see, various lines have direct correlations to our assembly code, and we use them very closely to actually construct this. So in this comparison statement, we are comparing I to the size of the array to see if it's equal, and if it isn't, then we break out. This can be seen here. We set the value of the array at I equals a key. We de-increment I. We have a double comparison statement within our while loop, so essentially we need to make two comparisons here and here, and then we increment j, and then we find the array value of j plus 1, and we set it equal to j, which can be seen here. And then in our increment code, we also take care of setting the value of j plus 1 equal to key. So as you can see, there's very direct correlations, and if I go ahead and run this insertion sort, we can see that it does indeed sort the array. So now we're going to go ahead and jump into the linear search, and this is going to take a little bit to get set up as it is slightly different in comparison to our insertion sort. It requires different C code. So I'm going to go ahead and uncomment all of this, and then we're going to go ahead and clean, build, and then connect to our target. And now we are going to have Connor come in and explain the merits of linear search.
All right, so over here on the left-hand side, we have the C code for linear search, which corresponds to our ARM code here, our assembly code. So here you can see the loop here is the main for loop for the linear search. Up at the top here, we instantiate, this is our I variable. And down here we are getting the value in the array at element I, and then we compare that to the key we are looking for, and if we find it in the array, then that key is what we return, and if we don't find the key in the array, then we will return -1. So when we run it, you can see that the result of the linear search was -1 because we did not find the value we were looking for in the array. So that is linear search.
Okay, now I'm going to talk about a few of the things that we would have done differently had we been given more time on this project, or if it would have been started earlier in the semester or anything. So first off, insertion sort is a fairly simple algorithm to implement. The time complexity is n squared. If we would have had more time, we probably would have done shell sort, which is a slightly better algorithm in terms of time complexity. Also, as you can see, we implemented linear search and insertion sort. We would have done a more complicated linear search or a search algorithm in general had we been given more time, but that was all time